Programs that perform the same action every time they run are all well and good. But most interesting computer programs do something a little different each time they're run, whether it's because they got differing input or even because a user is actively interacting with them. Today, we're going to explore the very basic conditional if and else statements. To start this off, let's create a new Java project in NetBeans. I'm going to call mine conditional statements. And I will allow NetBeans to create the main class for me. To keep things clean, I'll get rid of all of our comments. And now we're good to go. To allow us to write more interesting programs, we're going to quickly learn how to do some basic user input in Java. At this point in time, we don't have the knowledge base to fully grasp the intricacies of what we're about to do. But we should be able to have a basic understanding of what's going on and certainly repeat the process on our own in the future. While writing to this panel down here is kind of a simple fire and forget process, reading input in Java can be a little more complicated. User input is put into a buffer that our program accesses when it's prompted to. Therefore, we need to declare a variable that will allow us to access this buffer when we need to get some new user input. For this, we're going to use the scanner class. Let's call our new instance reader. NetBeans yells at us here because scanner lives in the package java.util, which we need to access explicitly. We can do that in the line here, or of course, we can always just import the java.util package. Okay, here's the part where we kind of have to take a leap of faith and jump a little bit ahead of what we're really ready to completely and totally understand. We need to assign a value to this reader variable of type scanner so that it links with this window down here where our user will be entering their input. To do this, we're going to set its value to the value of a brand new scanner object. But this scanner object is going to be created with a type argument, that of system.in, which happens to be the link to the input stream our users will be using. Like I said, this is some heavy-hitting stuff, and we certainly shouldn't expect to understand how this works on the low level right now. For now, know that reader is connected with our input stream down here, and our scanner reader has the function next, which allows us to access the input that the user has just entered into the stream. Like most functions, this function simply returns that input, so we're going to have to create a string in which to store that input. Once we've done that, we can use our printline function to print that value back out to the console. Let's see that at work. When we run our program, nothing appears to happen. But in actuality, our console here is waiting for some user input. If we type into this console and hit enter, it will echo right back at us. We can make this a little nicer to use by having our program prompt the user for input rather than simply waiting quietly. Okay, at the beginning of this video, I promised you we'd learn about conditional statements, and we're about to do that. But first, let's make a quick modification to the user input portion of our program. Rather than acquiring a string, it's going to be a lot easier if we learn conditional statements working with a user-provided integer value. So let's change the value or the type of our input variable to an int. Reader.next returns a string, but there's a similar function called nextInt that will return an integer. We're certainly not going to bother putting any error handling in our very simple program, so know that if we accidentally provide this Java program with anything besides an integer, the program will crash. So what exactly are conditional statements? Well, conditional statements allow us to send our program down different paths, executing different lines of code, depending on whether or not something is true or not. In today's video, we'll use conditional statements to print different responses to our user, depending on the value of the input they give us. Specifically, we'll let them know if the value they've given us is less than, greater than, or equal to the number 10. To start this process off, let's set up our output cases. If our user provides us input that is greater than 10, let's print out more. And if the user provides us input that happens to be less than 10, let's print out less. Of course, if we run this program right now, it will reach lines 15 and 16 and simply print out more or less, both of the lines. What we need to do is use conditional statements to make sure that only one of these two lines executes in any program run through, and that the proper line executes, of course. You may have noticed that the default project NetBeans created for us divides our code up into segments that have these brackets around them. We can further divide our code into segments using brackets of our own. Convention dictates that once we've created a new set of brackets, a new segment of code, we then add a tab before everything between them to make our program more readable. Once we've sectioned off our two print line statements, we're now ready to provide cases that must be true if these statements are to run. To do this, we preface our new sections with the Java if statement. If is a Java keyword, and it's followed by two parentheses, between which we put the statement to be evaluated. If Java determines that the statement we write between the parentheses is true, the code in the following brackets will execute. If Java determines that the statement is false, the code in the brackets will be completely skipped. This if statement, we're going to give essentially two pieces of input. We're going to give it the variable input, which if you remember contains the integer value that we got from the user. And we're going to give it the explicit value 10, which is what we're comparing it to. Java understands the greater than and the less than comparison operators. So if we make this if statement, if input is greater than 10, then this system.out.println command will only run if the user has provided a value that's greater than 10. Now we need to provide an if statement to make sure that our program doesn't always print out less anyway. We could use the less than operator to ask our program to print out less whenever the user provides input that is less than 10. That would be good in almost all cases, but if our user provided the input value 10, our program would print out nothing. To fix this, we can use the less than or equal to operator to ensure that our program always responds to the user input. Now, let's quickly run our program to make sure that it works. There's our prompt for input. Let's start by giving it a value greater than 10 and pressing enter. There's the more response and no less response. That is what we expected. Our program doesn't loop, so we're going to have to run it again to test the less output. And this time, let's give it the value 10, which should trigger our less than or equals. However, it turns out that there's a slightly easier way to write this program. When we write a conditional statement, or rather a pair of conditional statements, in which we're always going to execute one of the two code blocks, it's probably a good time to make use of the else keyword. The else keyword must follow a bracketed if block, and then is followed by brackets of its own. The else statement will evaluate to true and execute the code between its brackets if the code between the previous if brackets was not executed. If we run this program, we will get the same results as we did before, with one less bit of logic code to write. Let's end this video with a brief run through of what other operators we can use in our if statements. And then we'll take a look at what to do if we need to compare items that are not primitives. In addition to the greater than and less than operators, we can also make use of the equality operator, which is true if the items on both sides have the same value. Make sure when you're using the equality operator that you do not, by accident, use the assignment operator instead. In some instances, your program won't compile, but other times it will compile and you'll get very weird results. If you'd like to use the opposite of the equality operator, you can use not equals, which returns true if the two items do not have the same value. It's important that we not attempt to use these operators when comparing instances of a class. We should only use them when we're working with primitives. To show this, let's modify our program so that we now take a string as user input. We'll see if this string is equivalent to this secret password code. And if it is, we'll print out yes. If it's not, we'll print out no. Now, you'll notice that NetBeans is giving us a warning here. And in fact, if we attempted to compare strings with some different operators, NetBeans would let us know that our program is probably not even going to compile. That's because Java does not expect us to compare instances of a class with these operators. Instead, classes should expose functions that allow us to compare them logically. Almost every object in Java has a few functions for this purpose. One of the most common is the equals function, which takes an object of the same type and lets you know if they're equivalent. This function returns what's called a Boolean type, which is a primitive type of its own that can have a value of either true or false. Our if statement understands how to evaluate this Boolean type. Let's run our program quickly, and let's start by inputting a bad string. And then let's input password to see our program work. That's the basic of if-else statements. I would encourage you now to play with some of the comparison operators that we looked at and try nesting if-else statements within each other. As a very last note, you may sometimes see if statements without their following brackets. This is valid syntax and is basically the equivalent of putting the entire statement